Hey everyone, so this is a worked example for how to draw half-life graphs. So you're using a lot of your math skills in this because we're drawing a graph based on a table of data. Firstly, we need to fill out and complete the actual table here, showing the mass of the sample. So in this question, we've got a sample of francium-223, so that's a radioactive isotope, and its half-life is 20 minutes. So that means if we start off with our sample of francium, and we know that it's 1,000 grams to start with, so you can picture we've got a 1,000 grams chunk of francium. So if you wait 20 minutes, well, half of that francium will have decayed and turn into a different isotope. So we want to measure how much francium is still remaining after each half-life. So after 20 minutes, which is one half-life, obviously there's half of that 1,000 grams remaining, so there's only 500 after 20 minutes. So now there's only 500 grams in our sample. So then after the next 20 minutes, so two half-lives, well, half of that 500 grams will decay. So then there'll only be 250 grams of the radioactive atoms left. So you can hopefully see the pattern that we're halving the mass of radioactive atoms every time, and that's where half-life gets its name. So we have 125, then we have 62.5, then we have 31, and I'll just round it off to whole numbers to make it a bit easier. 63, 32, 32, 16, 8, 4, and 2. So you can see if you wait 180 minutes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 half-lives, and there'll only be 2 grams left of the radioactive atoms. So 998 grams will have decayed to become a different isotope. Alright, so we've completed our table, which measures the mass against time. Now we need to graph it using our math skills. So we'll start off by drawing a Cartesian plane, but since we're only using positive numbers, we'll focus on just the positive quadrant of the Cartesian plane. So we've got our x-axis at the bottom and y-axis at the top. The next thing we need to do is label the axes. So on the x-axis, we're measuring time. So time is nearly always on the x-axis, whatever you're graphing, because it isn't affected by anything. Time always just happens, and it's usually the other variable that changes. So we're measuring time in minutes. We always put the unit in brackets. And then on the vertical axis, we've got the mass of francium remaining. Mass of francium-223 remaining. And again, we need to put the unit, which is grams. Alright, the next thing we need to do is write our tags. So we need to choose a number pattern to label our axis. So along the x-axis, we're going up to 180. And we should use the same tags as in the table here. So our number pattern is going to be counting in 20s. So I'll split it in half. No, half won't work. So we'll go 20, 40, 60, 80, 100, 120, 140, 160, and 180. So obviously you should be ruling this out with a ruler to make sure each distance is exactly the same. And I'll just label a few of the tags, but you should be labeling every single one to make it clear. And we'll label 100 too. All right. Next, we need to label the y-axis too. And in this case, we need to think of a number pattern. We always start by looking at the top number. So the biggest number we need to put in is 1,000. So we'll put 1,000 at the top. And if we've got a nice rounded off number like 1,000, it's good to count in hundreds. So it's probably the easiest. So we'll go 500 is halfway. So then we'll need to count 1, 2, 3, 400. And then 6, 7, 8, 900. Alright, so again, you should label each tag, but I'll just label a few of these. Alright, the next thing we need to do is plot all our coordinates to make our graph. So remember that a table like this is an XY table, which you've been using to plot graphs for a couple of years now in maths. So the time is the X and the mass is the Y, which means each one of these pairs is a coordinate. So this coordinate here, remember the X number goes first in our coordinate, so this is the point 0, 1,000. And then the next coordinate is at 20, 500, because we always write the X and then the Y. So now what we need to do is plot all these coordinates onto our graph and then join up the dots with a curve, which will show the half-life graph. Okay, so let's plot the coordinates. It's probably a bit big. Okay, here we go. So the first point is at 0, 1,000. So 0 on the X, 1,000 on the Y. The next point is at 20, 500. So that is here. Then 40 to 50. Here. 60, 125. A little bit higher than 100. 80, 63. 132. 120. 16. So you can see we're almost right down at 0 by the time we get to these last few. 4 and 2. All right. So there's our coordinates, and you can see it's a nice curve, and that's exactly what we expect on a half-life graph. So then you would sketch with your pen a nice curve as neatly as you can that joins up all the coordinates. Hopefully it's a bit better than that one, but you get the idea. You don't join the dots with straight lines, but we try and fit a curve to the whole graph. Okay, so that's our half-life graph. We've labeled all the axes. The last thing we need to do is put a title in. So it's the half-life graph of francium 223. Alright, so there is how to draw a half-life graph.